All right, here are the practice problems for Chapter 6. We're doing sections 1, 3, and 4. Go ahead and jot these problems down, and this will be the video to go over all of these things. Here we go. All right, in exercises 1 through 4, tell whether the information in the figure allows you to conclude that point P lies on the perpendicular bisector of LM. Explain your reasoning. So, does P fall on the perpendicular bisector of this segment? Well, let's see. We've got a perpendicular line passing through. Okay, we see that because of this. Also, we have that LN and NM are congruent to each other. Okay, now that is a property of a point being on the perpendicular bisector of the segment. And since this line is in fact perpendicular due to this right angle here, we do know in fact that point P does fall on the perpendicular bisector, okay? If these tick marks were not here, then the answer would have to be no, because all we would have is a perpendicular line. We don't know that it has to be the perpendicular bisector. But since those tick marks are there, that tells you that point N is on the perpendicular bisector of segment LM, okay? So the answer here would in fact be yes for question 1. Question 5, find the indicated measure, explain your reasoning. Notice here that these lengths are congruent. This line is perpendicular to GJ, therefore this is the perpendicular bisector, and point H is a point on that perpendicular bisector, therefore it has to be equidistant to the endpoints, G and J. Since HJ is 4.6, that means that HG has to be 4.6 also. That is the perpendicular bisector theorem. Same thing for question 5, perpendicular bisector theorem applies. We've got a line going through, we've got perpendicular here, we've got these things are congruent. Therefore, this is the perpendicular bisector. So I guess this would probably be the converse. And then that means that these guys have to be congruent because it's a perpendicular bisector. It has to bisect that segment. So here we would do 5x equals 4x plus 3. Subtract the 4x, we get x equals 3. It says solve for AB, so we're going to plug that 3 in. This would be 15. This would be 15. Life is good. Final answer of 15 for AB. Question number 9, tell whether the information in the figure allows you to conclude that EH bisects angle FEG. So here's FEG. Does this EH here in purple have to be the angle bisector? Well, let's take a look here. We pick point H on this ray. Notice that these tick marks are telling us that point H is equidistant to the sides. Notice that these right angles are in fact confirming that we are taking the shortest possible path, and it appears that point H is in fact equidistant to these sides. Therefore, we can conclude that yes, this does work, and this would be the converse, right? Converse says if you are equidistant to the sides, like point H is, then you are in fact on the angle bisector. So this would be the converse of the angle bisector theorem, the CABT. Number 11, tell whether the information in the figure allows you to conclude that DB equals DC. Explain your reasoning. The answer here in 11, there's one big thing that's missing. The answer is going to be no, and the problem is that these are not marked as right angles. Okay, they certainly appear like they might be right angles, but they are not marked, and we can't assume it. Therefore, we can't conclude that BD and DC have to be congruent, right? D is on the angle bisector. We see that these tick marks exist, right? So D is on the angle bisector, but is it taking the shortest path to the two sides? We can't know that for sure, so the answer has to be no, okay? We would need these right angles to be here to confirm that for sure. Number 13, find the indicated measure, explain your reasoning. Notice here we have the right angles confirmed, okay? And so these are taking the shortest possible paths. That's what we need. This must be the angle bisector. Therefore, angle ABD must be 20 degrees. Since the bottom part is 20 degrees, DBC is 20 degrees, that means that ABD has to be 20 degrees also. FG, notice here we are on the angle bisector. These tick marks, these arc marks tell us so. We are taking the shortest possible paths. That means that these segments have to be congruent, and I can say x plus 11 equals 3x plus 1. Subtract x, subtract 1, we get 10 equals 2x, divide by 2, x equals 5. And we're going to solve for FG, plug in 5 here. Looks like this is going to be 16. If you plugged in 5 here, you would get 16 also as a nice little check. FG should be a length of 16. Last question, number 16. Notice we are, in fact, on the angle bisector. Point L is equidistant to the two sides of the angle. And that means that we are on the angle bisector. We see the tick marks. We see the right angles, which confirm this. So 7x has to equal 3x plus 16. Subtract the 3x. Divide by 4. X equals 4. And now we want KJL. So it looks like we're going to plug in 4 here. Looks like it's going to be 28 degrees. Let's do a quick check here. 3 times 4 is 12, plus 16 is also 28 degrees. So this is going to be 28 degrees here, since we only wanted the small part, not the entire thing. If we had asked for KJM, that would be 56 degrees. Okay. So there you go. That's the angle bisector theorem, converse of the angle bisector theorem, perpendicular bisector theorem, and the converse of the perpendicular bisector theorem. 6.3, now we're talking about centroids. Okay, remember, in question number 1, it says that point P is the centroid. That means that all of these blue segments are what we call medians. They go from vertex to the midpoint of the opposite side. If QN is 9, okay, the question is, what's PN? Well, remember, the relationship is a double half relationship. That means that PN is going to be 18, all right? And then that means that QP, it says find PN and QP. Well, it says QN is 9. Excuse me. Let me start over again. QN is 9. My apologies. And remember, this we break up into 2/3 and 1/3. Okay? 1/3 of 9 is 3, and double 3 is 6. Okay? So it's broken up. QP has to be 3. PN has to be 6. Okay, 3 and 6. 3 plus 6 is 9. 3 is 1/3 of 9. 6 is 2/3 of 9. I apologize for the mess up there. Just kind of read the information incorrectly. Number 5, point D is the centroid. Again, so all of those blue segments are medians. Find CD and CE. It says that DE is going to be 5. That's 5 right there. So that means that DC is going to be 10, right? Double half. And then the whole thing is going to be 15. So CD would be 10, and CE would be 15. We call that the centroid theorem. Okay, centroid theorem. Here we go. Point G is the centroid. So again, all of these segments are medians. BG is 6, AF is 12, and AE is 15. Let's draw that in. It's not in there. This whole thing is 15. Find the length of the following segments. Well, FC, well, since point F has to be the midpoint, since this guy is 12, this guy has to be 12 also. Okay, that's how medians work. They go from vertex to midpoint of the opposite side. Well, midpoints break up those segments into 2 congruent parts. So if AF is 12, FC has to be 12. Number 10, BF. Well, if this BG is 6, doesn't GF have to be 3? Okay, and so BF would be 6 plus 3, which is 9. AG, well, this whole thing is 15. From A to E is 15. 2/3 of 15 is 10. And this little guy would be 5. So AG would be 10. And GE would be 5. Okay. Notice that's a double half relationship. Vertex to centroid is twice the length as centroid to midpoint. 10, 5, 10 plus 5 is 15. And then finding the coordinates of the centroid of a triangle. Remember, there's a painful way and an easy way to do this. The easy way is to add up all the x's and divide by 3. Add up all the y's and divide by 3. 2 plus 8 is 10, plus 5 is 15, over 3 is 5. 3 plus 1 is 4, plus 7 is 11, divided by 3 is just 11 thirds, or you could say 3.66666 would work as well. So that is section 6.3. That's the centroid theorem, and then finding the coordinates of a centroid. And then 6.4, remember, is the mid-segment theorem. Now we're not connecting vertex to midpoint. We are connecting midpoint to midpoint. So take a look here. We've got a triangle, ABC, and notice that DEF is supposed to be the mid-segment triangle, is what we call it. And so DE is a mid-segment, EF is a mid-segment, and DF is a mid-segment. And question 1 says, find the coordinates of D, E, and F. This is just good midpoint practice. So let's go ahead and do that. Remember, the midpoint formula is x1 plus x2 over 2, comma y1 plus y2 over 2. You are going to have to do this on the quiz on Thursday, so you might as well get used to that. So D, you have to find, let's clear this. D is the midpoint of A and C. It looks like A is negative 5, 2, and C is negative 1, 2, 3, negative 1, 2, 3, 4, 5, 6. And let's go ahead and find B as well. B is 1, negative 2. Okay, so point D is the midpoint of A and C. So we're going to say take negative 5. It's plus negative 3, so I'm just going to say minus 3 over 2, comma 2 minus 6 over 2 because it's negative 6. Negative 5 minus 3 is negative 8 over 2 is negative 4. And 2 minus 6 is negative 4 over 2 is negative 2. Does it look like D is at negative 4 or negative 2? It sure does. Okay, but make sure that you can use the midpoint formula to confirm that. Point E is the midpoint of A and B. So let's go negative 5 plus 1 over 2, comma 2 minus 2 over 2. Negative 2 because it's a negative. Negative 5 plus 1 is negative 4. Cut in half is negative 2. 2 minus 2 is 0 over 2 is 0. Does it look like point E is at negative 2, 0? Yes, it does. It's right here. Negative 2, 0. And let's go point F. That's the midpoint of C and B. Let's go negative 3 plus 1 over 2, comma negative 6 minus 2 over 2. Negative 3 plus 1 is negative 2. Cut in half is negative 1. Negative 6 minus 2 is negative 8. Cut in half is negative 4. Negative 1, negative 4. That looks pretty good for point F. Negative 1, negative 4. So now question number 2 is where it gets real interesting. Show that DE is parallel to CB and DE is 1/2 of CB. Just to kind of use our space wisely, we're going to kind of go over here to do this work. How am I going to show that DE and CB are parallel? Well, here I have to show that their slopes are the same. Okay, and the slope formula is y2 minus y1 over x2 minus x1. So let's find the slope of DE from here to here, right? D to E, these points right here. So let's go y2 minus y1, negative 2 minus 0, over negative 4 plus 2, right? It's minus negative 2. And so I get negative 2 over negative 2, which is 1. Looks like a slope of 1 for DE. And now let's find the slope of CB. CB is right here and here. So let's say negative 6 plus 2. Subtract the y's over the difference in the x's. Negative 3 minus 1. Negative 6 plus 2 is negative 4. Negative 3 minus 1 is negative 4. And we get a slope of 1. Notice that those slopes are, in fact, the same. Therefore, the lines are parallel. DE does have to be parallel to CB because we have a slope of 1 and a slope of 1. Okay, that means that the lines are parallel to each other. Running out of space here, so let me go ahead and erase this. If you want to write all of this down, go ahead and pause the video and get that jotted down. But now let's do the distance formula to show that the length part of the mid-segment theorem works as well. So let's find the length of DE, square root of the difference in the x's plus the difference in the y's squared. And so from D to E, we're going to go -4 plus 2 squared plus, -2 minus 0 squared. -4 plus 2 is -2 squared is 4. -2 minus 0 is -2 squared is 4. And so we get radical 8, which I think is 2 times radical 2. If you buddy system the 8, it's 2 times 2 times 2. Buddy the first 2's. One of the 2 just goes out. The other 2 stays inside. So DE is 2 radical 2. Let's find BC or CB. The x's is -3 minus 1 squared plus -6 plus 2 squared, right? Because it's minus -2, so it's being plus 2. And I get -3 minus 1 is -4 squared is 16. -6 plus 2 is -4 squared is 16. And we get radical 32. Now, what's radical 32? Notice we can buddy the 4's. Okay, there's nothing wrong with that. So we get 4 radical 2. 2 stays inside. Notice, isn't 4 radical 2 twice as big as 2 radical 2? Okay, has to be, right? Think of 2 radical 2 as x. If DE is x, CB is 2x. Okay, and so we do see that DE is 1/2 of CB. We are good to go. Let's go back to this view, a little easier. DE is a midsegment of ABC. Find the value of x. Well, if DE is a midsegment, then that means point E is a midpoint, and x has to be 6. Not much easier than that. DE and BC, DE has to be half the length. So whatever BC cut in half is, it's going to be x. So x has to be 13 for number 9. Let's go up here. In exercises, let's kind of erase this area. Give us a little cleanliness here. All right, so in exercises 11 through 16, xj is congruent to jy. Let's see why this is important. YL is congruent to LZ, and xk is congruent to kz. That tells you that these are all mid-segments, right? J is a midpoint, K is a midpoint, L is a midpoint. So all of the mid-segment theorems apply, and in this case, there'd be 3 of them because there are 3 mid-segments. So what does JK have to be parallel to? Has to be parallel to YZ. And what does XY have to be parallel to? LK. Okay. So there, it's just the triangle mid-segment theorem, but we can apply it 3 times because we have all 3 mid-segments drawn in. So there you go. Those are all those problems. If you know how all of those work, the quiz should go very, very well for you. I think this is a good opportunity to get a good grade. Feel free to watch this video again if I went through anything a little too quickly, but good luck. Do your best.